Hello, welcome to Chapter 3, Homework Questions 108 to 113. Question 108. Use the relationships in the diagram below to solve for x and y. Justify your solutions. So as you look at the problem, you should recognize that you have two parallel lines. And so that potentially could give you some information. You have lines that intersect, so you're dealing with vertical angles as well. You have a triangle, so you could use the triangle angle sum theorem. So a lot of different things that you can look at. You have straight angles as well. So let's just start with the two angles that we do have. We have 61 degrees in the triangle, but we don't have any other information about the triangle yet. We do have the 43 degrees, where you have two lines that intersect. So we do have vertical angles here, and so this would be also 43 degrees. Now, that doesn't answer the angle of x, but it might give us some information that we could use. We also know that if you have a straight angle, that they are supplementary. So 180 minus 43 is 137 degrees. So we also know that's 137. And then now as you look at your parallel lines, you might recognize that this parallel line and this transversal, so right here, you have same side interior angles. You could also do corresponding angles, which means angle x matches up with this angle down here. So that does appear that angle x is equal to 137 degrees. And once again, we could do that by corresponding angles, could be same side interior angles. So a lot of different possibilities there in terms of how you looked at that. If we know that that's 137, we also know that the angle inside that the angle inside has to be 43. Once again, you could do that by corresponding angles or straight angle. Now that we have enough information there, we know that 61 degrees plus 43 degrees plus y is equal to 180 degrees by the triangle angle sum theorem. And so this is 104 degrees plus y is equal to 180 degrees. And then if you subtract 104 from 180, you will get 76 degrees. And so kind of talked my way through that, but when you make sure that you guys are justifying your answers and your solutions here, that you're talking about vertical angles and straight angles and corresponding angles, same side interior angles. So lots of different ways to go about that problem, but use the justification that works for your thought process. Question 109, the area of the triangle below is 25 square units. Find the value of h. Then find the perimeter of the entire triangle. Make sure you show all your work, of course. So as we look here, we got 4 feet and 6 feet. So we know the total base, if we're looking at that side in terms of the height, would be 10 feet. We also have the possibility of some right angles there to maybe help us if we need to. So we do know the area for a triangle is 1/2 times the base times the height. So let's plug in the information that we do know. We know the area of the triangle is 25. We know the base is 10 feet, and we don't know the height. So it appears that we actually have all the information we need to find the height using the formula for the area of a triangle. So if we take half of 10, that's 5. Divide both by 5, and you get the height to be 5 feet. So we now know that h is equal to 5 feet. But it also wants us to find the perimeter. So to find the perimeter, we do need to do some additional things because we don't have the side lengths of the bigger triangle there. So now that we know the height, we have 2 right triangles. So we just need to be able to find the hypotenuse of each of those. So I'll start with the smaller one. We'll do 4 feet squared plus 5 feet squared is equal to, and we'll just call this x squared. So that's 16 plus 25 is equal to x squared, so 41. So when we take the square root of both sides, we get the square root of 41. That's the exact, but if we want the approximation, then that would be about 6.4 units. So we'll say x is approximately 6.4. Now we'll go ahead and do the same thing with the other triangle. We have a base of the right triangle of 6, so that's 6 squared plus the height is 5 squared. This side we'll call y this time. And so we get 36 plus 25. and that will be 61. And we take the square root of both sides, and we get y equals the square root of 61, or, once again, approximately, so we can add them all together, would be 7.8. So y is approximately 7.8. So to find the perimeter, we're going to take the 6 plus 4 on the bottom, or the 10 feet, plus the two approximations, 6.4 plus 7.8. And if we add that up, what will we get? 24.2. Now, because we approximated the two answers, the perimeter then will approximately be 24.2 feet. And once again, the reason it's an approximation is because we approximated the side lengths of the triangle as well. Question 110. To help out the bowling alley on weekends, one of the arcade games was a bin filled with stuffed animals. A robotic arm randomly grabs a stuffed animal as a prize for the player. You are in charge of filling the bin. Alright, part A. You are told that the probability of getting a stuffed giraffe today is 2 out of 5. If there are 28 giraffes in the bin, what is the total number of stuffed animals in the bin? So we're trying to figure out in terms of how many total we have. So that means we don't know the number in there. So we don't know the total outcome. So we'll just call that X. We do know there are 28 giraffes though, total. But we want the probability to be 2 out of every 5. So 2 giraffes should be pulled out for every 5 total. So one way to do this is to set up a proportion. And then you can solve. Once again, you can cross multiply if you've learned that method, or you can just multiply by 5x. And when you do that, the x ends up canceling. You get 5 times 28. And 5 times 28 is 140. So 140 is equal to, and then this would just be 2x. So when you divide, you get x equals 70. So what does the 70 mean? That means there are 70 total stuffed animals in the bin. All right, so that's part A. Let's move on to part B. The next weekend, you arrive to find the bin contains 22 unicorns, 8 gorillas, 13 striped fish, and 15 elephants. A shipment of stuffed whales arrives. What is the probability of getting a sea animal, which is a whale or a fish, if you add 17 whales to the bin? Express the probability as a percent. So you can see lots going on here. So we need to figure out, kind of reread that now to figure out what it is that we need. So we have 22, 8, 13, and 15 animals in, and they got a shipment of whales. What is the probability of getting a sea animal if you add 17 whales to the bin? So we have 22, 8, 13, 15, and we're going to add 17. So that would be the total that you have. So let's figure out what the total is. So add those numbers up, and what do we get? So 75 would be the total. What is the probability of getting a sea animal? So which ones are our sea animals? We have our fish, and then we have our 17 whales. So that would be a total of 30 sea animals over the total possible outcome, which is 75. And since it wants us to express it as a percent, we do need to divide, and that is 0.4. So as a percent, that would represent 40%. So 40% probability that you will get a sea animal. All right, last one, C. You are told that the probability of selecting a stuffed alligator needs to be 5%. One weekend you arrive to find there are exactly 3 alligators left. How many total animals should be in the bin to maintain that probability of 5% for an alligator? So how many total animals need to be in there? We know there's 3 alligators. We don't know the total. So I'm just going to put that over Y because we don't know how many. We need to figure out how many total need to be in there with those 3 to represent 5%. 5% is 5 out of 100. So if we multiply both sides by 100Y, that's going to get us 300 is equal to 5Y. And so once again, I just multiplied both sides by 100Y. And that allowed me to get 300 equals 5Y, divide by 5, and it looks like there needs to be a total of 60 animals in the bin. So if you're working, you need to make sure that there are a total of 60 animals to make sure that you maintain that 5% in terms of an alligator. So 3 out of 60, if you divide that, you should get 5%. Once again, saying that that's the percent of alligators, the chance of actually selecting an alligator from the bin. Sorry. Question 111 is a checkpoint. The problem is a checkpoint for writing linear equations for multiple representations. When you do these checkpoints, be aware that this is really a point in the course where you should have mastered this skill. So if you have not, if you go through this problem and you're still struggling with things, make sure you get some extra help. Write a linear equation that represents each situation. So on part A, an equation for the line at the right. So we're going to take the line at the right. We need to identify the slope and the y-intercept. The y-intercept is given to us at 0, 4. So we need to use our slope triangle to create, to find out what our slope is. Or we could also pick 2 points. So on this one, I went down 4, and it looks like to the right 8. So therefore my slope would be negative 4 over 8, or negative 1/2. So you could have drawn a different slope triangle, might have did something like this as well. You could also go in this direction. Lots of possibilities there, but either way the slope is negative 1/2, and so you have enough information to write your equation. Y equals negative 1/2 x plus 4. And remember, there's different ways to approach on how to write an equation. So if I show you something and it's not the way you did it, just double check that your method or your idea still works as well. B, an equation for a line perpendicular to the line at right and passing through the point negative 1, negative 3. So let me get rid of my slope triangles here. So once again, we want an equation that is perpendicular to the line at the right. So what's important there is that we know the slope was negative 1/2. So the perpendicular slope is opposite reciprocal, which would be a positive 2. We also want it to go through the point negative 1, negative 3. So negative 1, negative 3 is not necessarily on here, but the idea is that it has to go through that point. So we have a slope and a point. You potentially could use your slope and say up 2 over 1, up 2 over 1, up 2 over 1, and that could give you the y-intercept at negative 1. That's one way to do it. Another way is to use your equation, y equals mx plus b. Plug in the information that you know. 2 times negative 1 plus b. And this method, in terms of writing the equation, works a little bit better when your y-intercept is not as nice as this one. So if we add 2, we do get b equals negative 1, which is the same thing we saw from the graph. Once again, using the equation method works a little bit better when your y-intercept is not a nice whole number or an integer, or also when you don't have the grid in front of you. So y is equal to m, which we found to be 2, and then we have x, and then our b value was minus 1. So y equals 2x minus 1. And so if you draw on that line, you kind of see, does that appear to be perpendicular? And it does. All right, on to C. An equation of the line passing through the points. So this one has nothing to do with the graph. This is just saying if you have 2 points, can you write the equation of a line? So first we can find the slope, the change of y over the change of x. And if you want to use a table to do the same thing, that's fine. So it appears we're going to get a slope of 2/5. And we're going to use, I'm going to use the 0.43, so only positives, and then we'll use the slope that we just found was 2/5. Plug in the information that we know. Y is 3, m is 2/5, times x is 4, plus b. And then we'll solve for b. So 2/5 times 4 would be 8/5. Remember, 4 is over 1, so that's 8/5 plus b. Subtract 8/5 to both sides. Well, not equal. And if you take 8/5, 3 minus 8/5, you will get 7/5. So 7/5 is equal to b. And so that gives us enough to write the equation y equals your slope of 2/5 times x plus 7/5. So here's an example where your y-intercept is not a nice integer. So using the graph would be in the table to try to find the y-intercept would be a little bit more challenging on that one. And the last one, what do we have here? D. At the concert, Elite Parking charges $15 for the first hour and $7 for each additional hour of parking. Write an equation to represent the cost for the parking and T hours. So when you look through here, you're looking at what information do we have? They charge $15 for the first hour, so that's a one-time initial fee, and then $7 for each additional hour of parking. So we want to write an equation to represent the cost for the parking. Now you got to be a little careful here because the cost will be equal to. We do know we're adding $7 for each additional hour. So just to kind of show you, I'm going to just do 7t because that's usually what we think about here, plus the 15. But when you do it this way, when you look at it, if t is 1, you're getting charged $7 plus the 15. Well, for the first hour, you're only getting charged $15. So how could we set this up so that it's not 7 times t, where we want that to be, when this is 1, we want that to cancel out. So one way to look at this is to say 7 times, instead of t, if we do t minus 1, now it's 1 minus 1 is 0. So it will cancel out that initial first hour of being charged an additional $7, and then plus your 15. So if you look at it this way, when I plug in 1, now it's 7 times 0 plus 15, which is 15. And then when I plug in 2 hours, now it's 2 minus 1, which is 1 times 7 plus 15. So it works out. So a little bit different there, but it is important that you understand when you are being charged that first hour, how do you deal with that in terms of an equation? And you could simplify this. This would be 7t minus 7 plus 15. So that's 7t plus 8. So this is another way that you could have potentially written it if you would have thought about, how do I deal with that first hour being 15 and then each additional hour adding 7 each time. So once again, a couple different possibilities there. Question 112. Patty lives 20 miles northeast of Matt. Simone lives 15 miles due south of Patty. If Matt lives due west of Simone, approximately how many miles does he live from Simone? Draw a diagram and show all work. So I just read through that. I got confused. I need to go back and reread it, make sure I understand what it is that they're asking. So we can answer the question. The other thing is I'm going to kind of draw it this time as I read through it. So Patty lives 20 miles north east. So you got a little compass over here. North is up, east is to the right. So northeast, we're going to go in that direction. So 20 miles northeast. So on the grid, I'm not saying this is accurate, but to give us a starting point. So we have 20 miles northeast. So we're going to go in this direction here. And we're just going to say this is 20. So Patty lives 20 miles northeast of Matt. So Matt's here, Patty's here, because she's the one that lives 20 miles northeast. Simone lives 15 miles due south of Patty. So 15 miles due south of Patty. So we'll go 15, and then this is Simone. Now, I don't know that this is a right triangle, so maybe I'll go a little further just to... Not necessarily. I don't want to make that assumption because I don't know yet. If Matt lives due west of Simone, so now we're going due west of Simone, how many miles does he live from Simone? So now that I actually read the rest of the problem, if he lives due west, then they are going to have to match up. So that means that right here is where Simone lives, and then Matt lives due west of Simone. So if Matt lives due west of Simone, approximately how many miles does he live? So we don't know this value, which now that we have it all set up, we can see that it will be a right triangle. But reading through that, initially I had no idea. So it was nice to kind of set it up on a grid to be able to see that. Now you don't need the grid to do that, but you do have to recognize if you're due south and due west that they have to match up. So it looks like we can use Pythagorean theorem. We'll say x squared plus 15 squared is equal to 20 squared. So x squared plus 15 squared is 225, and 20 squared is 400. So if you subtract 225, that's going to give you 175. And then when you take the square root, of both of them, you get the square root of 175. And then if you take the square root of 175, that is approximately 13. So we'll say x is approximately 13.23. And that would represent miles on that one. So we drew the diagram, we showed our work, and we came up with that. So how many miles does he live? So Matt lives approximately 13.23 miles from Simone. And so make sure you answer the question as well. Question 113. List a sequence of transformations that demonstrates that the two figures below are similar, then find y and z. So in terms of the sequence of transformations, you might be able to recognize that on here, here we go, A and W match up, so this point matches up with this one, and then D and Z also match up. So if you think about this, you could rotate your figure, I guess, depending on how you want to rotate it, you could rotate it counterclockwise, and then potentially you could translate it and then dilate it based on one of the vertices. So for me, the way I'm thinking about it, and there's so many different ways that we can look at this, I'm thinking of a rotation in this direction, counterclockwise, and then I would translate it so many units to the right to match up the vertex A and W, and then I would use a dilation to make it the same size. So once again, that's kind of what I'm looking at. We can figure out what I'd have to dilate it by in just a second, but we got to look at some of the side links. So let's match some things up here. So A, D, and W, Z, they match up. So I'm going to write the big figure over the little one. That'll tell us what that zoom factor is, if that's what we're kind of looking for, the ratio as well. So Y over Z. Then we can also go C and Y match up. So this point matches up with this one. And once again, if you can't see that, you can go look at the similarity statement. So now this is equal to 6. Or no, we're going to go the larger one first, 15 over 6. And then we'll do the next one. B matches up with X. And so the next side length is 21 over 8.4. And then the final one is going to be 24 over Z. So we actually have a couple ones we can use in terms of finding that. 15 over 6 and 21 over 8.4. 15 over 6 can be reduced. You can also check that those ratios are equivalent. They should be, since they tell us that they are similar. So let's go ahead, and I'm going to use these two first to find the y value. So this would give us 6y is equal to 45. Divide by 6, and if you divide by 6, you get 7.5. So y is equal to 7.5. Then we can go ahead and use, I'll use the 15 over 6 again here for this one. You could use the 21 over 8.4, but with the decimal, I'm just going to go ahead and do it this way. So it looks like when we multiply, we're going to get 24 times 6, and that's 144. And that's equal to 15z. Divide by 15. And 144 divided by 15 is 9.6. So those were the two unknowns, 7.4 and 9.6. And then to look at the ratio, if we do take 15 divided by 6, that's 2.5. So when we dilate it, if we're going from the first to the second, we would dilate it by a zoom factor of 2.5. And I think we have answered all the questions on this one.